Don't forget to record. That would be a bad one to. You can believe that it's our last class? This like weird extra Monday of classes. So many days of math. Well, we've got a tiny bit of material. Turn that frown upside down. But I know. So I know. Well, we're doing K-maps, so Karnaugh maps. But I've already done. We're gonna do 4 variables for Karnaugh maps. So we did 3 last day, we're gonna do 4. Make that extension, mostly because I wanted to keep that question on the final, because then I can mark you really nice on it. Is that proper English? No. Is that what I'm gonna do? Yeah. So just, yeah. I don't think I'm gonna repeat that, Ashley, but yeah, exactly. What even is proper English? Anyways, so Niall has a question about our final. King's English. So your final grade is going to be made up of, now where are your, what's our breakdown? What did we do? Oh, I think I passed it. So assignments are 45%, so that's a lot. Tests are 30 and the final exam's 25. So so a lot of your grade is from your assignments. We didn't do any quizzes. So one key thing though, so I don't have, actually maybe I'll bring this in just so I can steal stuff from it. Hey, hello? Anybody home? All right. Create new note, import, done. It's like I've done this before. All right, here we go. Where is it? Okay. First things first. Okay. We'll do a little reminder down here, but also from the course outline here. Okay, this is, it wasn't that important before. Now it feels a little bit more important. Okay, so, oops, oh no. I covered all my other ones. I'm not thinking it anymore. I'll fix that later, don't worry. No, of course I'm thinking it. You guys are awesome. Okay, so here's the thing. You have to get at least 45% on the final in order to be eligible for a pass. So even though the final exam is only worth 25% of your grade, it's very possible that you could have a passing grade, right? But I need you to be able to pull together at least, you know, half the material on the final exam. Are you talking to me, Ashley? I did not. I washed my hair. But thanks. It's really funny. Anyways, I did not get a haircut. I just washed my hair. So you have to have at least 45% on the final exam. Okay, in order to be eligible for a pass. Okay, I think that's pretty fair, right? you have to have at least half of the material that we've covered and be able to produce it on a final exam. So, okay. Let's see here. So, trying to go back to, does that answer your question? Wow. Cool. So at least 45. I am not worried about any one of you. So you will be able to do this. But this is just here so that, you know, we're not having people slip through the cracks here. Okay, first things first, I need to pull these to the forefront on top. It's important. Uh-oh, how do I do it? There. Okay, slipped off. That's okay. I'll fix it before I make the PDF. I promise. I wouldn't let something like that go by. All right. So your assignments. We didn't even have any quizzes. Okay. So I posted a review. So it started as kind of like a summary, and then it just morphed into a practice final. Yeah, the little fun quiz, I'm calling it a test. So we can split it up. Unless you wanted to take up assignments, I might play around with it. See what gets you better grades. Psych. No, it's so that I can play around with it and do whatever I want. Bamboozled in a good way. So I can, yeah, the final. Look at this itty bitty final. That's what we'll call it, an itty bitty final. I will say this, I have already spent about 20 hours making the final. So pressure's on, guys. Pressure's on. Easily, actually. Easily. Yeah. Well, the idea of me spending time on it is so that it's better and easier for you. So I don't leave you hanging. Yeah, it's on all topics. And what we'll do is yeah. We'll go through the final exam. So I called it a final exam review, whatever. It's essentially a practice final. And so we'll go through this, but let's talk about the Karnaugh maps first. And then we'll kind of see how much time we have left, maybe cherry pick some of these problems. I also want to have office hours sometime later in the week. And maybe in the chat, let me know if Wednesday or Thursday would be better. Thursday's kind of cutting it close, but I'm open to either. We have a department meeting all day tomorrow, so that's out. But I can have office hours on either Wednesday or Thursday. And then it's too late. All day, Reed, you heard me. 24 hours. Yeah, that has happened actually. Someone comes into my office like an hour before a final. They're like, hey, can you show me how to do this, like this core concept? Yeah, I can, but not very helpful, Ashley. All right. But what I wanted to what I wanted to say was, so I talked to Leslie and Laura, who teach the other sections, as I think maybe you know. And turns out I've been all loosey-goosey with our testing style. I just let you go, be free, do whatever, just get me the test. Great. So what we decided, and I guess Leslie, she has everyone with their cameras on and she records it. And so I said, okay, well, this is a final, so let's be proper about it. So we'll go through, why not? Let's just talk about it now. So for the final exam, oops. Yeah, don't we end at 4 for you guys? For me, it's 3 to 5. How do you think I feel now? It's dinner time. So for the final exam, you will need to be on Zoom with your camera on so I can watch you. I don't know. With your camera on. So that I can watch you. Insert creepy face here. It's my creepy face. Okay. And it will be recorded. I'm like, yeah, open book's open book, who cares? But this is just to make sure that you're not, you know, kind of talking to each other, getting help from one another, or I still don't really see how I can police that, but it's a final exam. We'll go through the motions, right? So, so those are the rules. Yeah. Yeah, if you've hired your mom to write your test for you, then you should make her dinner. All right, so it is open book, but the expectation is that you're not going online. Okay, so, but like I said, how can I know that? I guess if you're sitting there like this on your, then I can kind of tell. Okay. And it's all gonna be, it's just a PDF that I'll post on Moodle. And so, oh yeah, so totally if you're using Google for a calculator, go for it. Yeah, if you think I'm buying one, you're insane, especially at this point. So you're gonna have 3 hours. Okay. TI 89, that's fancy. The final is 3 hours. Okay. And you'll have 15 minutes to upload your work on Gradescope. And you will have an additional 15 minutes, because you're pretty good at that now, additional 15 minutes to upload your work to Gradescope. Mid-test naps, it's a thing. straight out of Rutland. So it's 3 hours and it's from 9 till noon. On Friday. Okay. So you'll have to show your face, be here in Zoom. What's nice is that if I have any corrections or anything, then I can just tell you guys about them. And if you do have any questions, then we'll just be here in the same room and just kind of be available to answer questions. So the test is open book. How do I say this? But closed to the internet? Yeah, right. No, just so you're not like, yeah, looking stuff up and, yeah, sure, you can look on WebAssign. I don't really see the problem there. So the test is open book. I don't know what you would grab from WebAssign though. Just worry about all the things you didn't do or got wrong or yeah. So maybe have your work ready somewhere. Yeah, do-overs. So the test is open book, but closed to the internet. I'll say within reason, right? Calculator, etc. Okay. Okay, so proper. So if you do have any questions about that, then let me know. Otherwise, we're going to finish Karnaugh maps because as was pointed out in the chat, we didn't quite finish. In fact, here, these are the exercises that you all did right away. If you're anything like me, you set it and forget it. Okay. So here, Karnaugh maps continued. From last day. So we'll do kind of review by example, I guess. Okay. So remember, this is the sum of the min terms. Okay. 0, 2, 4, 6 are referring to the labels, the binary labels. Okay. So of the disjunctive normal form, the DNF. So here, I'm going to scooch these down. Boop. This is the sum of the min terms. And these are the I should use a different color here. These are the binary labels from the DNF. Oops. So then what we said was, okay, to make a Karnaugh map, well, the reason we make a Karnaugh map is to simplify a disjunctive normal form, right? So that we can have the simplest machine possible. So what we need to do is we need to set up our map, and then we need to plot these values in it, right? And so we have our map with 3 variables, and so that's what we did last day. We did 3 variables. We started with 2, but that was pretty silly. Then we moved to 3 variables, and then today we're going to go to 4 variables, and then we'll be rich with 4 variables. All right, so we set up our map, and with 3 variables, we can do something, we can do something like W and X, Y. Oops, doesn't need to be that long, but it will. Remember, each of these variables can be either on or off, right? 0 or 1. And what's important here is the X, Y, right? So we need to alternate. X can be on or off, and Y can be on or off. So we're going to have different combinations. But as we move through the table, we can only have one literal, which is either X or Y. Only one of those can change in each flip, right? So it doesn't actually, oh yeah, so here you can have W or W bar, it doesn't matter because it's just the one. So they'll just loop through W bar, it doesn't matter. But here it matters that you have, the literals are only changing by one thing for each move. Okay. So what we can do is we can start, and I can't remember, so in my notes I'm using 0, 0, but I can't remember if I actually did the X bar, Y bar. They mean the same thing. How about we do both? Well, let me check first. What have I done? Okay, so I was using just the 0, 0, 0, 1. It doesn't matter. You can use zeros or the negation. So you can use, 0, 1, right? Which is the same as W bar and W. W. Okay. So then here, we'll start with 0, 0. And then I'm only allowed to change one literal at a time. And so what I'm going to have is I'm going to go 0, 1, 1, 1, 1, 0. And then we said, okay, well, this thing actually loops back to 0, 0, right? So just because we've blocked it off this way, we can actually kind of, oh, yeah, that's what I was going to do. I was going to put it on a toilet paper roll and have it just kind of going around for each of your problems. Trouble is you'd have to write on a toilet paper roll and have one kind of just laying around. I don't know, seems weird. So this, a donut would work better, but difficult. All glazy. I love donuts. All right, enough about that. Yeah. Oh, I was gonna use that. Dang it. X bar, Y bar. Oops, this would be the equivalent of X bar, Y. This is X, Y, and this is X, Y bar. Yeah. So whichever one you prefer, I've got just the binary in my notes, but you can use the actual literals if you want. Toroid. I don't know what that means. A toroid. Anyways. Oh, fun. A shape with one hole all the way through. I hope that's not a coffee mug. Hey, it's like coffee. All right, so what we have to do is we have to remember that, okay, these labels correspond to different binary codes, right? And so 0 is the code 0, 0, 0, right? And so what we do is we put a little 1 here. Yeah. And then we remember, how about we do this? How about we put all the labels in here so that we get into the groove. This is label 0. Okay, this is, I'll do the label numbers are in green. Okay. A coffee mug and a donut are topologically the same thing, but that's topology. We're talking Boolean algebra. Yeah. But let's talk topology. I'd rather. So here we have 0. Spicy. 0, 1, and then remember we have to skip to 2 because if you're reading these, so you would have 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0. 0, 1, 0 comes before 0, 1, 1, right? If you convert it to just the decimal, right? 0, 1, 0 is 2, right? So you can convert them to their labels and vice versa. And so this is my third label. And then same thing, I start down here, 4, 5, 6. I don't know why I hesitated. 7. 7. Locking it in. Oh, so here, so the reason we have to put this one first is because you're only allowed to make one change. So here we start with 0, 0, okay? And then I'm only allowed to change one of the digits. So I've decided to change this to a 1. So now when I move over, now I'm only allowed to change one of the digits. If I go back to 0 here, cool. It's really important. So I'm going to finish it, but yeah, cool. So if I take this 1 back to 0, then I've already covered this one. So that's why I have to change this 0 to a 1. And then I go to 1, 0, and then it cycles through to 0, 0 again. Okay, cool. In fact, here in red, notice the order. And that goes for this whole column, right? 0, 1, 2, 3, 4, 5, 6, 7. Having that kind of under control is going to be really useful when we get into 4 variables. Okie dokie, artichoke. Here we go. So now I want to map out 0, 2, 4, and 6. Okay. So I'm going to make a fresh map here. Why not? I'm going to do, I'll do the numbers just because they're easier and quicker to write and require very little thought. So 0, 2, 4, and 6. In those spots, we put 1s, okay? So here, 0, 1, 2, 3, 4, 5, 6, 7. So in my mind, I go through each of the labels and I put a little, a 1 wherever I have a binary label in my disjunctive normal form. Okay, so here, put 1s in 0, 2, 4, 6. Oh yeah, that's fine. So here, if you want to, it's just easier to look at 1s. But if you do like a W bar, X bar, Y bar here, and then W bar, X, Y bar, is that what you were doing, Ashley? Yeah, that's totally fine. As long as you see that there's a group here and a group here and a group here and a group here, because what we're gonna do, and I gotta move this down, what we have to do here is we need to make groups because we're trying to remove any redundant terms. Okay? So remembering that this thing, yeah. So here, exactly. So here, remembering that this thing loops through. So here, how do I show it? What I'm going to do is I'm just going to transfer, because this is where I have all my ones. I'm actually going to rewrite this 0, 0 column over here just so it's easier to look at. And just kind of imagine 0, 0, 1, 1, right? Kind of transferring it over here. Okay. It doesn't matter, you can loop it through. Or sometimes, or rather often, we would show it like this to say that either way, I'm going to be able to make a group of 4 here. Remember, we're making groups in powers of 2. So groups of 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, right? So we can make groups in powers of 2. So here, because we have 4 ones, our ideal situation would be to be able to lump them into a group of 4. Okay. So here, what we do is we see, okay, well, depending on if you prefer to look at this square, I actually wouldn't do this normally. It's just to show you that it loops through, right? Usually we would just have this and this. So what we need to do is we need to identify whatever variable is held steady throughout everything, right? So W here changes between 0 and 1 for all of these. So W is just, it's changing, so it's allowed to change, okay? Here, if we're talking about, so here I'll do W bar W, and in this column, I've got X bar, Y bar, and here I've got X, Y bar. So the only thing, right, so X bar is allowed to be X bar and it's allowed to be X. So the only thing that's being held steady is this Y bar. Okay? So the only thing in this grouping the only literal, I should say, held steady is Y bar. Okay, so this group is summarized by Y bar. So this group is summarized by Y bar. Okay. Okay. So use a Karnaugh map to simplify this function, whatever it is. I know it has 4 different terms full of W's, X's, and Y's, right? And as determined by this binary label, right? And so I'm able to simplify that whole thing and say that therefore f of W, X, Y is Y bar. Okay. Now, I'll admit, there are times where you're not able to, most often, you're not able to group all of them into one group. But as soon as all the ones are captured, you're done, right? So if you're able to cover everything with one group, that's it, simplified. Fancy, right? So, No. The final is going to be a sprinkling of tests 1, 2, and then this new stuff. If you want, you can have a look at that review, the practice final that I posted on Moodle. And it has a summary on it. Throughout it, I should say. Okay, so let's do this next one. So same idea. We're going to move a little bit quicker here because we've talked about these labels. So now what I'm going to do is I'm going to look and say, okay, I've got 3 variables, w, x, and y. So I'm going to set up my map again, w, x, y. And I'm going to do 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. If you kind of say it out loud, I don't know, they just start kind of bubbling out. So now I'm going to put 1s in the labels of 0, 1, 2, and 3. Okay, so 0, 1, 2, 3. Looks like I'm able to make a group of 4 going all the way across here. And the one thing that's held steady, right? X is allowed to be X or X bar, Y is allowed to be Y or Y bar. The only thing that's being held steady here, and this is the row for W bar. And so here, this is W bar. And so therefore, f of w, x, y, we can just summarize as w bar. Okay. This next one will have multiple groupings, okay? But you always want to try to make your groups as large as possible. There are a few times where making smaller groups reduces the number of terms, but that's going to be so rare. So when I plug the first question into the calculator, oh, okay, yeah. So in that case, so that online calculator that I posted, it uses A, B, C. And so C bar, and so we can write, and typically if we're typing, right, we can say or Y prime, usually that's how we read it. Yeah. So the prime is the not. So you'll just want to link your first, second, and third variables. They can be W, X, and Y, or A, B, C. But in the end, it's just saying that the last variable is going to be the negation of it. And that's why it's got a C prime. Nice. So yeah, so I did find the calculator was a little bit tough to read initially, right? But once you kind of say, oh, okay, I can figure out which one corresponds to A, B, and C, and D in the case of 4 variables later, then you're off to the races. Awesome. So they're getting the same answer, which is great. And we have no don't care conditions. So I didn't read that far. Who cares? All right. So again, now we have 3 variables. So I'm going to start with my map, W, X, Y. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay. And now I'm just going to get into that rhythm of putting a 1 down wherever I have a label, right? And so 0, no, 1, 2, 3, 4, 5, 6, 7. Okay. So just be careful when you're putting these labels down. All right, I'm only allowed to move in powers of 2, right? So powers of 2 does not include 6, otherwise I'd make a big group of 6, right? But I have to move from 4 to 8. Okay, so what I have to do is I have to split this up into 2 groups of 4, right? You make your groups as large as possible. So even though it might be tempting to do a group of 4 and then a group of 2, you can actually absorb another variable by making 2 overlapping groups of 2. So what we'll do is we'll have this group, okay? That group can be summarized as, okay, well, so W is allowed to change, and it looks like X is allowed to change as well. So this group is summarized as Y. Okay. This next group that I'm going to make, well, I have to capture these leftover values, but also if I can, I'm going to make a group of 4. So here I'm going to have this other group of 4. Okay. And then for my simplified function, I just add these variables together that I find. Again, it looks like W is allowed to change over 0 and 1, okay? X is held steady, so X is on, and then Y is allowed to change. So this one is X. So therefore, f of W x y can be simplified as y plus x. Okay. So we'll do one, let's see here. One that's a little bit trickier, right? Remember we were referring to example 3 and example 4. So return to example 3. I even made a note that we would be referencing this quite a bit. And so example 3, it has a DNF we found. So we went through all that work and we found the disjunctive normal form, which was a series of, let's see, where was it? Where's example 3? I think this is example 3. Example 4 here. So here we found our disjunctive normal form, but then we summarized it with the sum of the min terms, right? So your DNF is going to have each of the 3 variables, and it's going to be a sum of the products. Okay, so just to remind you that we have worked on this problem before, and we do know how to get here. We found that, oops, f of wxy is the sum of the min terms 1, 3, 6, and 7. Okay. So we want to find a minimal sum of products which is usually referred to as an SOP. For f of w, x, y. What does that mean? Use a Karnaugh map to simplify. Okay. So we'll lay out our map again. We've just got 3 variables. We're just about to head into 4 variables, but let's just do this one last hurrah here. All right, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. And we're getting pretty good at this now. So 0, nope, 1, 2, 3, 4, 5, 6, 7. Okay. So my goal is to gather up all my ones as kind of as soon as I can, right? So you could go through and you could make a group of 2 here, and then you could make a group of 2 here and a group of 2 here. I would say that's kind of inefficient because then you're making 3 groups when you could just get it done with 2 separate groups, right? So they don't have to overlap. You could have a group here and a group here. In fact, that's probably the easiest way that I see this going down. So my groupings here, I'm going to have the pink one, I'll call it group number 1. This one, okay, now I'm not spanning all of W, right? I'm held steady in W bar, right? And so this is going to be W bar. And then X is allowed to change, but Y is held steady, right? So the ones that are being held steady, those are the ones we jot down. So W bar, Y. Okay. And that's how we summarize that cluster of terms. Do you need more, Ashley? Oh, cool. Gotta swap them labels. All right, cuidado. All right, so my next grouping here is gonna be this one, right? You're trying to capture all these ones in as few moves as you can possibly make, right? So my second term is going to be summarized by, okay, so W is not changing, right? X is not changing either. The only one that's changing is the Y. It goes from Y to Y bar. Okay? So what we get is we get WX. Make sure I did that. Because the Y is the only thing that's changing. So what we can say then is therefore f of wxy we can summarize as w bar y plus wx. Okay. This is really simplified from what it was. I'm going to copy this. Hope it's the right one. And you know what? I'm going to switch these. Oops. I don't know why I wrote them like that. Y bar Z. Laziness, that's why. Okay. So here, WXY, these are doing the same thing, right? From our DNF, which was this one, right? Here, this is our disjunctive normal form, but what we've found using the Karnaugh map is we've simplified this to make this. Okay. So that's the whole reason we use Karnaugh maps, is to be able to do something a little bit simpler, but still doing the same job. Okay. All right. Oh yeah. Something got lost along the way. I can count on Zach for picking up on stuff like that. W, X, Y, Z. Then it would be X, Y, Z. Changes everything. What do I do? Redo it or ignore the previous? I've only got two options. Oops. I should have used X, Y, Z instead of W, X, Y. Same idea. You'd have to change everything. Things would just bump though. X bar, W, no, Z, X bar, everything would just jump one variable. Anyways. Oh, all right. X, Y, Z. I still have 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. I've still got 1, 1, 1, 1. This here is X bar X bar Z bar, or X bar Z, sorry. And this one is going to be X. And the only thing not changing is the Y. I think I made it more confusing, but it's good. Now you can see, doesn't matter which variables you use, as long as you follow all the rules. I should be consistent though, shouldn't I? All right, 4 variables. Let's talk about 4 variables. We could list out all those binaries and find the labels, but we already did that in another class. I can't remember when. So in 4 variables, our map becomes, okay, so here's the only kind of new thing is that we have WX being sliced with YZ. WXYZ is typically kind of the order that we use, but it doesn't actually matter. So now, just like we had 0, 0, 0, 1, 1, 1, 1, 0 at the top, we're going to have those same binary labels running down the left-hand side. So we're going to have 0, 0, 0, 1, 1, 1, 1, 0. So again, notice the order again. So it's the same. Because the rule says, well, I can only change one literal as I move across here. I can only change one of these literals at a time. So I have to have kind of a weird order. Okay? It affects how we put our labels on here, right? And so, but across the top, nothing changes. 0, 0, 0, 1, 1, 1, 1, 0. Yeah. So now our labels, oops. And once you've done enough of these, you can kind of start kind of just following the pattern, just keeping a heads up that just the same way that we have 0, 1, 2, 3, right? We're gonna go this row, and then the last row, and then go back to the third row, right? So what I'll show you here. So we have 0, 1, 2, 3, 4, 5, 6, 7. 8 is on the last row, right? That could be confusing. 8, 9, we're expecting 15 labels, right? Because we have 16 slots. 10, 11, 12, 13, 14, 15. Okay. So here we need to be careful. Yeah, same pink here, because these labels and these labels are kind of out of order. Okay. So we kind of move from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 5, 6, 7, bump all the way down to the bottom row, 8, 9, 10, 11, 12, 13, 14, 15. Kind of fly around this thing. Okay. So let's see here. Besides that, right, now we need to keep track of, okay, just like our map kind of rolled around on our toilet paper roll, right, or our toroid, the same thing happens now from top to bottom, right? So now this thing actually loops the other way as well, right? So now we're on this sphere, I guess. Okay, so note the table cycles from the top and bottom as well as from the left and right. Note the table cycles from top to bottom as well as left and right. So that can be confusing because some of these that I was looking at, it wasn't obvious that I could connect a label here with a label here, right? Because they're so far apart, but then you have to think, okay, well, I could just cycle through top to bottom as well as left to right, or a combination of the two. Yikes. Okay. So again, we're just keeping track of which variable is being held steady, and then that's the one that we keep out of these groupings. Okie dokie. Let's do an example. Find a minimal sum of products. Find a minimal sum of products, SOP, representation for f of w, x, y, z, which is the sum of the min terms 0, 1, 2, 3, 8, 9, 10. what this is actually asking us to do, right, is use a Karnaugh map to simplify f of w, x, y, z. Use a Karnaugh map to simplify f of w, x, y, z. Okay. So again, we need to keep track of our labels, right? But if we've got that rhythm 0, 1, 2, 3, 4, 5, 6, 7, 8 is at the bottom, right? That's key. 9, 10, 11. Bump back to the third row, 12, 13, 14, 15. I know I'm just emphasizing them when I say it. It's not very useful if you're trying to just listen. So I'm going to make my map W, X, and Y, and Z. 0, 0. And again, I'll use the binary labels. If you prefer to use W bar, X bar, W bar, X, just good moral support. Yeah, just counting through them. Maybe just keep that as a little reminder. Have it playing during the final. No, that'd be distracting. 0, 1, 1, 1, especially if you're not working on a Karnaugh map. You're right. 0, 1, 2, 3, 4, 5, 6, 7, 8. That was me going all the way down to the bottom. Anyways, we'll have a chance to review them. 0, 0, 0, 1, 1, 1, 1, 0. Okay. So my job is to put a 1 in all of these boxes. Okie dokie. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm out, but just to keep going, 11, 12, 13, 14, 15. So I need to make groups as large as I can, right? Remembering that this thing cycles through both top to bottom as well as left to right, right? So I can make all kinds of weird groupings here, and I will, okay? One thing that's kind of the one that jumps out at us is, of course, this group here. Okay. I'll call this my group number 1, and down here, I'm going to say my group number 1 is what? The only thing that's not changing here is that we have 0, 0, right, in the first row. So W bar, X bar. So what I can do is I can summarize this whole thing as W bar, X bar, and then everything else just kind of changes and is allowed to run through. So this is going to be W bar, X bar. Okay. So now I've got a couple of different options. The main thing that I want to kind of alert you to is that just like we were able to group kind of whole lumps from the right-hand side to the left-hand side, we can do that again with just the corners, right? So what happens is we're going to go like this. What? And that also makes a group of 4. Okay? Because what could you do? You could move this 0, 0 column over here, right? Yeah, hard. Or I think it's hard at least. But then I could also cycle this 1, 0 up top here, or rather this 0, 0 row down here if I wanted to, right? So imagine you're kind of going 0, 0. And then so here, you've got a 1, you've got a 1. And then you've also got, so now you've moved these guys kind of from this top row, you've moved them down here. But then you've also, you can move this row over here, kind of imagining 0, 0. So then now this would move over here and this would move over here. Okay? So that's tricky. So now you have this group here. I actually prefer to just keep them where they are, but I just wanted to show you what's happening here. Okay. Maybe I should have made this a different color. I'll make this one green. Oh, too many little dot, dot, dots. Okay. So then this pink box looks like this. Or if you prefer, I would just do the corners, right? I wouldn't bother moving stuff around because it gets confusing. But if it helps, then go ahead, do it. See if I care. But this pink box, okay, let's think about what's being held steady and what's changing. Up here, right, I'm looking at this row versus the first row versus the last row. Okay. The first row I have a W bar, and then the last row I have a W. So W is allowed to change, but it looks like X is being held steady, right? And so X bar is X bar in both of these. Okay. So here I'll call this my second grouping. I'll start with an X bar. What else is being held steady? So now I'm talking about Y, Z. So I've got Y bar, Z bar, and then I've got Y, Z bar. So Y is allowed to change, be between Y bar and Y, but my Z bar is constantly Z bar. And so I have X bar, Z bar. Okay. Now, I have this little guy here, and this one totally threw me for a loop because I just wanted to make a group of 4 here and move on with my life. But here, it loops through, right? So we can actually make another group of 4. Okay, so just be really careful. This group can go with this group. And that's my third group. Okay, I didn't see that right away, but the more of these that you do, the quicker you'll see these groupings, right? And so now I don't have any, well, I have some troubles, but because it's still weird and new, right? But we get better at seeing these things. The more times we've seen weird stuff like this and gone, oh, that's, okay, got me. And that's why I posted that calculator so you can check your work. So here, what's happening? W is allowed to change, right? So I go from W bar to W. Okay, fine. So it's out. X bar and X bar, so it's being held steady. So in this third grouping, I've got X bar again. And then looking at my columns here, it looks like I've got Y bar, Z bar, and Y bar, Z. So Z's allowed to change, so all I'm keeping here is the Y bar. So I get Y bar. But now I've lumped all these ones that I've marked down from this min sum, right? And so here, therefore, f of w, x, y Z, 4 variables, I almost did 3, 4 variables, is just going to be W bar X bar plus X bar Z bar plus X bar Y bar. W bar X bar plus X bar, Z bar, getting ahead of myself, plus X bar, Y bar. Yeah, little tricky, a little bit rock and roll, but got this. Okay. What if we go back to example 4, and I'm just going to make sure that I have the variables in the right order this time before I go ahead and do it. So let's revisit example 4 to simplify using, to simplify the function, I somehow put a U in function, but not where it's supposed to be. To simplify the function using a Karnaugh map. All right, let's see if I can find it in our notes here from December 2nd. Example, haha, we will refer to this one as well. Hey, what do you know? So here's our original function, and then we found the disjunctive normal form. This is it. Copy, because I do not want to write that out again. You have it in your notes, I'm confident, because we did it the other day, last day. So, looks like I have W, X, Y, and Z, phew, so I'm not going to be able to muck this up too bad. And each of these terms have a component of W, X, Y, and Z. Okay, and then we found the sum of the min terms. Right, we went through and we found the sum of the min terms. Where was it? Yep. So we can rewrite the DNF from example 4 as a sum of the min terms like this. Okay, copy. From December 2nd, we have this. Okay, so this is example 4. So now we're going to use a Karnaugh map to simplify this beast into something a little bit nicer, hopefully. All right, we set up our map, and then we plot our labels from our sum of our min terms. So we've got Wx and Y and Z. And I always start at 0, 0, 0, 1, 1, 1. No, I'm afraid not, Michael. It will suck. Yeah. It's a little bit harder, right? But hey, I was gonna say this is real life. No one's using Karnaugh maps in real life. It's the idea. It's a state of mind. Karnaugh maps. It is pretty cool to be able to simplify these huge functions. So 0, 0, 0, 1, 1, 1, 1, 0. Okay. Yeah. What's his name? Maurice, I think. Maurice Karnaugh. Yeah. He's in New York. He's just a hop, skip, and a jump away. Yeah, solving these are cool. Instead of the Thug Life glasses, it should say K-maps. K-maps. All right. 0, 0, 0, 1, 1, 1, 1, 0. I know. I'm sure they're out there. They've got to be out there. No one does anything original anymore. Although that might be. All right. So kind of going through the flow of the labels, right? Just don't let anyone knock your groove here. We're going to put ones in 6, 7, 10, 12, 13, 14, and 15. Something about wish. Exactly. If we say it enough time, it'll come up. We'll start with Thug Life glasses. And then K-map glasses. We'll train it. Ironically, I think that algorithm might be using K-maps at some level. I don't know. I don't know about this stuff. I just know how to do it now. All right. Get in the groove. Start going through your labels. Put a 1 wherever you have one of these min terms. So 0, 1, 2, 3. I guess I should use my pointer. It's harder though because I want to be able to quickly draw. 0, 1, 2, 3, 4, 5, 6 has a 1. 7 has a 1. Then I go down to the last row, right? 8, 9, 10 has a 1. 11, nope. Third row, 12, yes. And then just to finish it off, 12, 13, 14, 15. 1, 2, 3, 4. Okay. On that calculator that I posted on Moodle, right, it just lets you plug in. So you just click the labels. So one thing, you could fill out your map yourself, or you can click on the labels and it'll do the same thing. So you have 2 options for solving these using that little calculator. All right. First thing, first group I see is, of course, this 4 across. So call this group number 1. What is this group called? Well, the only thing, so yeah, I guess ones everywhere. The literals are ones, but then ones and group number 1. I got way too many ones. Maybe I should call it group A. Doesn't matter. So this this group here. Oh yeah, so do you mean these ones or these labels? Yeah, so here from these min terms, you're going to put ones just because it's easier to see ones. I mean, you could put the labels down here. So 0, 1, 2, 3, 4, 5, 6, 7, right? But because I have 6 and 7 here, that's where I started putting ones here. And then the 8 starts down here, right? That's where it gets weird. 8, 9, 10, 11, 12, 13, 14, 15. And now we're grouping these things. Does that kind of help, Dermot? Cool. So this group can be summarized, so it's changing over Y and Z. So what I'm looking at, if I have a whole row, well, it can just be summarized by WX, right? Because that's what this row is. So this I can summarize as WX, okay? Remembering I make my groups as large as possible for the most part. For us, yeah, definitely we'll just make our groups as large as possible. So now I'm trying to capture these rogue ones, right? Remembering that things can flip across here, right? But I need to move in powers of 2, right? So wait, what was the Star Wars reference? I need to know. Rogue ones. Hey, pretty good. Wait, so my one of my shirts is a Star Trek shirt, and then I made a Star Wars reference. And I have a hard time keeping the two apart. Ashley said it best. And the math is out of this world. All right, so I guess I've got my theme. So then here, what I'm gonna do is I'm gonna try to collect these rogue ones in as few moves as possible, right? So, and remember, you're allowed to overlap. In fact, it's encouraged, right? You don't want to make just a group of 2 when you can make a group of 4. So here we're going to make a group of 4 and call it our second grouping. And I mean, you could put down what these groups are beside here, but I just like it nice and clean. I just label them and then bring them over here, but it doesn't matter. So the second group, how can we summarize this thing? Well, let's look at our rows, right? So W is allowed to change from off to on, so that's out. X is being held steady at just on, right? So we've got an X, so I'm gonna write that down, X. And then here, right, Y is on and Y is on, right? So it's not changing. Z is on and then it's off. So what I can do is I can summarize this as just Y being on. So I've got X, Y. And then my last grouping here, got one little solitary one. I can't say rogue one too many times, right? One solitary. I could circle it on its own, but because it's close to this one, I'm going to make a group of 2 instead. But I don't see any groups of 4 here. I confirmed it on that calculator. And so here, this is my third grouping. And how can I summarize this? Well, I've got W is being held steady as on. X is allowed to be on and then off, so he's out. So W is dependable. Maybe that's a nice way to think about it. The ones you can rely on through these things. X is kind of on, it's off, who cares, he's out. So here, right, the only thing that's happening is that Y is on and Z is off, right? So Y, Z bar. So that can happen, right? Especially if we have these small groups, then the small groups mean larger products, right? Because there's not enough to kind of absorb. So therefore, what we can say, therefore, and we're referring to this disjunctive normal form, remember it spanned 2 lines, right? This we can rewrite as wx plus xy plus wyx bar. Let's see this. I'm checking out your okay, I'm guessing that's your old one. Hey, I opened the same one twice. How annoying. It's important. It's not even right. Hey, that's beautiful. So, yeah, the first one, it's a learning curve. All right. So what we can say is g of w, x, y, and z is simplified to wx plus xy plus wyz bar. That's way better. No, these groupings were arbitrary, right? So as long as you have a wx somewhere, an xy somewhere, and a wyz bar somewhere, and those are the only things you have, you did it. Okay. Brush your shoulders off, Ashley. This is what it feels like. It's good to be king. So, queen in our case. Nah, we'll be king. Gets lonely at the top. So the one thing that I want to show you before I kind of end things, yikes. Oof, I know. Is I want to go to that practice final that I posted, because one of the questions you know how to do, but it's set up a little bit strangely, but I want to just show you how to do it, and then you're off to the races. So the final exam summary is the practice final that I posted. It's at the very, very bottom of our Moodle page. So if you haven't grabbed it yet, go grab it. I'm working on the solutions. It's possible that I might just have answers to some of these. And the reason for that is because it can be too much of a crutch during the final if I have the fully worked out problem, and then you just need to change some numbers, because that's usually how it goes. So I'll post just the answers to a lot of these. And then if you do have questions, hey, did we decide on Wednesday or Thursday for office hours? I'm open to whatever. Any hoodle. Wednesday? You know what? Let's do Wednesday. Then we can feel all prepared and feel good. So, hey, Reed, do you mean we should do both? Because I don't think so, mister. Let's do Wednesday. Let's see what time is good. I don't know. You guys figure out a time. Let me know. I'm thinking like a 3-hour block. And you can kind of drop in, ask questions. We can work through some practice problems, but it'll just kind of be drop-in style and not mandatory at all. All right, so there's going to be 2 questions from the Boolean Algebra section, right? And so 2 long answers. So you're given a Boolean function. This one's in 3 variables, okay? And, oh, we're not doing this. Although you could. Multiplying is and, adding is or, x and y, or x and not z. There, you did it. I'm not going to do it though, because we didn't spend any time on that. But you're going to find the disjunctive normal form and express it in terms of the summation of the min-term shorthand. That's what we've been doing. And then construct the Karnaugh maps. This one you don't need to circle and simplify. You just need to make that Karnaugh map. Easy. Here, I'll give you a Boolean function, nasty like this, okay? And then you're going to construct a Karnaugh map for this thing, right? So it's a little bit more, it's a few more steps than we're used to, right? We're used to just getting the sum of the min-terms, but here we can generate the sum of the min-terms from this presumably DNF. So here, right? Because it looks like I've got all 4 terms being represented in each of these products, okay? So what we're gonna do here, from the practice final, okay. Yeah. I'll make a note here. Assume this is the DNF. Good. In fact, I'm going to change that on the test to say, consider the DNF of the Boolean function. Right. Then there's no doubt. All right, so what I'm going to do is I'm just going to copy this here, and I know that's cheating, but I'm also running a little low on time. So I have to. All right, so what you're going to do is you're going to rewrite this, right, in terms of on-off switches, right? So here it's 0, 0, 0, 0, right? To me, that's a label of 0. Right? You can always convert this this binary label into the label number, right? We're expecting labels from 0 to 15, right? Because I've got 4 different variables. So here we go. I'm going to rewrite this as, and maybe I'll use this lighter color, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 0, 1, just had to take a breath, I guess, 1, 1, 0, 0, 0, 1, 0, 1. Just double check that you got these all kind of copied down, right? You don't want to mess this up at this stage in the game. Here, you can convert all these. So here, this is the binary. So now I can make a label for each of these. That's just converting each of these binary to decimals, right? So here, 0, 0, 0 is 0. This is 0 plus 2 times 0 plus 4 times 0 plus 8 times 1, so 8. I'm sure there's a fancier way you could think your way through that. I'm going to try again here. Right? Remember that this is the 1 slot, this is the 2 slot, this is the 4 slot, and this is the 8 slot. Right? So this becomes just 1. This is the 8 plus 1 slot, so that's 9. Is it 1? Let me see here. I did jot this down before. It is. This here is the 1 slot, 2 slot, 4 slot. So now I've got 8 plus 4. So that label is 12. And here I've got 4 plus 1, that label's 5. Okay. So now I'm where I usually, or where we have been starting, right? And so therefore, f of w, x, y, z can be written as the sum of the min terms, 0, 1, and you want to do them in proper order, right? Because as we move through our table, we don't want to be doing something weird, right? We don't want to miss out on any of these labels. So 0, 1, 4, 5, 8, 9, and 12. Just count them to make sure you have the right number. In fact, count the number of clusters you have initially and just follow through. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Hey, so far so good. 1, 2, 3, 4, 5, 6, 7. Phew. So now, this is where we have been starting, right? So it's just got this added little step of generating the labels and rewriting as a sum of the min terms. Maybe I'll make that a part. Write it as the sum of the min terms, just to force you in the right direction. Doesn't have to say that. You need them to make the Karnaugh map. Okay? Technically, you don't need them if you do your map instead of using zeros and ones. You don't actually need them. Just makes it easier, I find. But if you wrote w bar, x bar, w bar, x, wx, wx bar here, and same with the top row, you could make all these, and you can try it, right? You could make a w bar, x bar joined up with y bar, z bar, and put a 1 in that map, right? So this step here is optional. I just find that it makes it a lot easier. Okay. So let's make our wx, y, and z. 0, 0, 0, 1, 1, 0, nope, 1, 1. I want it to go proper order, or improper in this case. 0, 0, 0, 1, 1, 1, 1, 0. Now I'm just going to put 1s wherever I see the label, right? So now I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see how it went, Zach. Hey, looking good. Let me get back to Zoom here. Nice. Okie dokie, artichoke. Remembering large groups, as large as possible. All right. They're all kind of hanging out over in this corner, so we should do a pretty good job, or we should be able to do a pretty good job of lumping these things. I'm going to start with this guy here. Call this my group number 1. If it's the whole column, right, that 1 can be summarized by just that column name 0, 0, which is y bar, z bar. So now, my next grouping, I think I'll make, and I did screw this one up when I tried it initially. Good thing I was able to check my work. But let's do this group of 4. That seems nice and tame. And it's kind of jumping out at us. So make that your second grouping. Okay. Now, what changes, what stays the same? For both of these, you've got W bar, right? X is allowed to change, so we ditch them. Here, Y bar is held steady and Z goes from on to off. And so we've got W bar, Y bar. Okay. And then the last one is a little bit sneaky, right? Because initially I just wanted to pair this one, this last solitary one with this one beside it. And then I forgot that it loops, the table loops around, right? And so we need to have a grouping like this. So this is our third grouping. And let's look at what that grouping would be called, right? So W is off and then it's on, X is off and off, right? And so we've got X bar. And then looking at the columns here, Y is off, and then Z is off, then on. And so we've got Y bar. Okay. So now construct the Karnaugh map. We already did that. And then use the Karnaugh map to simplify F as much as possible. Well, we did that as well. And then make sure you circle your groups and state what your groups simplify to. So that's what we're doing here and here, right? You can do it all in one go. That's fine. You don't have to break it up A and B. So therefore, F of W, X, Y, Z can be simplified as W bar, Z bar, sorry, Y bar, Z bar, plus W bar, Y bar, plus X bar, Y bar. So many bars. They're all off. Yeah. So, all right. Another way that you could do this, right? You could skip this. You could skip the binary labels, right? And just make a table like this. Option number 2. Skip the binary labels and make your map like this. And so we've got W, X, Y, and Z. W bar, X bar, W bar, X, W, X, W, X bar. Again, you're only allowed to make one change as you go, right? So instead of doing 0, 0, 0, 1, whatever, you can change it to the literals, right? Y bar, Z bar, y bar z, y z, y z bar. And then you can make your combinations here. W bar, X bar, Y bar, Z bar. Oops, go to primes. There, etc. What you would find is you would fill in the same spaces, so it doesn't actually matter. Oh my goodness, is it time? Congratulations. That's it. Now you know everything you need to know for this final exam. That's it. In a while, Crocodile, I'll send out an email. Let's say Wednesday for office hours. I'll pick a time that works, and if you can make it, great. If not, we'll set up some other time if you need help. You guys have been awesome. I'll let you go. Enjoy potentially your last class. I hope it's your last class. Bye, guys. Last class. Enjoy.